Thanks everybody for coming. So I'm Felix Geisendörfer. You find me on Twitter, on GitHubs as Felix GE. I have a startup here in Berlin. We're called Transloaded. We do file uploads and video encoding. We were one of the first users of Node.js, which also meant we were one of the first contributors of Node.js because it was not really doing everything we wanted. But I'm not talking about this. I'm talking about faster than C. And before I get into it, I want to apologize. Sorry about the title bait. We'll have a reasonable discussion about performance. I'm not going to make some claims that I cannot back up, but I think we're going to talk about high-performance JavaScript for sure. And I think the results in some of the stuff I was doing look very cool, even though C is probably still your tool of choice for some problem domains. So I want to make it like a battle. The battle is JavaScript versus C, or good versus evil. Oh, wait, the good parts versus evil, at least. We may even need the bad parts to win this one. And so, just a little backstory here. My story starts in, or my suffering, really, starts in early 2010. Because in early 2010, we had no MySQL module for Node.js. It did not exist. Many people in the community wanted such a thing, but it just wasn't around. However, what we did have was no SQL libraries. So go figure, NoSQL was first in Node. And now the NoSQL people doing SQL, it's crazy. But so then in early 2010, this guy came along, Masui Drive on GitHub. And he actually posted a message to the mailing list, the Node mailing list, and fixed a problem with promises, which are long gone. And then he was like, by the way, I started this Node MySQL module and linked to it. And everybody was like, wow, somebody's finally doing it. So I checked out the code, and I was really curious on how he did the libmysql binding, because back then it wasn't quite clear how we would do these blocking library integrations into Node.js. That's now a solved problem, but back then I was curious on how it would be done. And when I looked into it, I found something weird. He actually didn't write a binding to libmysql. He wrote a pure JavaScript MySQL client. And so I was like, wow, how did he do that? And so, well, if you think this is impressive, check this one out. This was before buffers became usable. So he had no buffer support in Node. He basically did his parser using JavaScript strings. I was like, what the fuck? This guy was crazy. Apparently what he did is also based on prior art, credit where it's due. He took the Ruby, a Ruby implementation that had done the same thing for Ruby, a MySQL module, and he ported that to Node.js. And so unfortunately, he never finished it. So he got it kind of working, but then kind of stopped working on it, and it went away. But while we're talking about buffers and old times in Node, here's a little piece of trivia. Buffers in Node used to be called blobs. Raise your hand if you knew that. Holy crap, you guys are good, because it was not a long time that buffers were called blobs in Node. It was 3 minutes and 15 seconds. Which is really a shame, because blobs to me would have been a much better name, because I'm sometimes talking about buffering data, but I may mean like concatenating strings or pushing stuff into an array. I don't always mean like a buffer of binary data. So it's a shame. Rest in peace, blobs. Oh well. Anyway, back to MySQL. So what Masui Drive's library really did for me, it showed me that MySQL can be done without libmysql. I had not considered this before. Ryan actually had not considered it before. He was really worried that MySQL would be a deal breaker for Node. And so I really wanted to use MySQL. This module was not continued anymore. It was based on strings. We now had buffers. So I was like, OK, maybe I can do this. So I started this module, and I wasted too much time on it. Instead of building my startup product, I built this module for like 3 months. But then it started working, and people started using it. So that was nice, right? But no good deed goes unpunished. And I actually traced this back, who came up with this. I think Sir Isaac Newton made the proof for it. And he called it the third law of motion. And it kind of goes like this. When a first body exerts a force, F1, on a second body, the second body simultaneously exerts a force F2 equals minus F1 on the first body. This means that F1 and F2 are equal in magnitude and opposite in direction. So I'm not as clever as Isaac Newton, that's for sure. But I can imagine if he was living today, maybe some of the stuff he would do. I'm sure he would be on GitHub. I guess we can all agree on that. And so, I don't know, maybe he would study like the community effects in GitHub. Maybe that would be his thing, I don't know. But let's imagine he came up with some bullshit like the third law of GitHub. And it could go like this. When a first person pushes a library L1 into a remote repository, a second person simultaneously starts working on a second library, L2, which will be equally awesome, but in a different way. So that's why we love GitHub, right? So that's what happened, but it can also hurt sometimes. I'll show you why. So this guy came along. Sunny's on GitHub, and he wrote a library called Node.mysql libmysql client, which is pretty much what you would expect it to be. It's a binding to libmysql. What he also did, he did some benchmarks. And I did some benchmarks of my own. And here's a recent one. And this is what happened. So on the left side is my library, and on the right side is his library. That's what you would expect, right? This is JavaScript versus C. Of course, libmysql is written in C. My library is JavaScript. And C is so much faster than JavaScript, right? So that's what I thought for a long time. But it felt wrong, because, I mean, haven't we gotten the marketing message V8 is supposed to be really, really fast, turning our code into assembly? And then they make Crankshaft and told us now it's going to be even better and it's going to analyze what our programs are going to do. And I mean, Node.js, that thing is going to solve world hunger and everything. So was I living a lie? Had I been lied to? Kind of. I mean, the stuff you read on the Node homepage is like crazy. Because V8 and Node are tools. They're tools. And performance is not a tool. If anybody tells you performance is a tool that you can just download and install, I don't know, they're crazy. What it actually turns out to be, I think what it is performance is hard work and data analysis. So if you expect this talk being me, like telling you, here's one little trick to do in your JavaScript, and now everything's going to be faster, I have to disappoint. But I will present some stuff that's useful, I promise. So anyway, I set out, and I tried this new approach that I'm going to show you, and I continued working on my library. And so this is what happened. I beat him a little bit. Maybe at least I can say I'm as fast as the libmysql client. So mine is, so the colors have changed, but mine is on the furthest to the right now. And as you can see, it's alpha 3, which means I'm spending time optimizing performance problems nobody cares about instead of finishing the thing. I mean, it's working, but I want to do connection pool and stuff, but I just geek out on this all the time. Anyway, so I told you about the third law of GitHub, and it could be bullshit, but I don't know. I'm starting to believe in it, because after I submitted my proposal and was accepted, this guy came along, Brian White, and he wrote a new library called Node.MariaSQL. And MariaSQL is a fork of MySQL, and they're continuing the development. It's actually one of the original MySQL guy. And they also continue to improve the client. So the MariaSQL client is actually non-blocking. So it fits much better with what Node is doing. Not only that, this guy, Brian White, he's really smart. So he knows how to do these bindings much better. And these two things combined led to this. It's tough. It's tough. Here I was thinking I was present like the fastest MySQL library on earth written in JavaScript. It's probably not going to happen. So is this the time to give up? Should I give up? Never. So I'm working on this new parser, and this is undone shit. It's not finished, and you shouldn't listen to it. But it's interesting because, once again, this is my old library against my new library. It's a new parser. It's not integrated in the module or anything yet. It's just running a very limited benchmark. But it seems like I can get a 2x performance increase, or almost 2x. And so I have reasonable hopes that I can at least get on speed parity with the MariaSQL module if I find the time to finish this up. But should I do it? Because wouldn't the third law of GitHub kick in and somebody just comes along and does a faster one? I mean, what's the point? So actually, I think I should do it, because I think we're getting close to the end game. Because the end game here is that we're going to run into one last bottleneck, and that's just creating the JavaScript objects. We're going to be able in JavaScript now, or we are already able in JavaScript, to parse these protocols really, really quickly. But both the C libraries, or the C bindings, and my code has to do the same thing. It has to ask V8 to create a new JavaScript object, like a row, and to give it column values. And if I want to use a library that's available in JavaScript, this performance penalty is probably going to be the same for me in JavaScript and the C++ people. So I think we will just end up at a very fast speed, where only V8 can make things go faster, but we will all get faster, the C bindings and my module. Also, we already won because MySQL server is already saturated. I don't know, unless you're serving data from memory and you have really a good hardware setup, I think a single MySQL client, either C bindings or the JavaScript, can fully saturate a MySQL server using one processor on a client. So this stuff is getting fast enough. So anyway, this is kind of cool, but what's even cooler is that I found out some stuff on how to do this stuff. So I studied a lot about how to write fast JavaScript, and I found out a few things that don't work, or at least not for me, for my problems. One thing, unfortunately, is profiling. Profiling is cool. The V8 profiler can do good things for you, but I found that profiling is mostly good for spotting small functions with stupid algorithms performing many iterations. So that's the kind of stuff where the profiler will be like, hey, you have this function, and you spend all your time in there, and then you go, you look at that function, you fix that function. It's really nice. But if you have a complex function with many primitive operations, it's not so nice. So for example, in my first MySQL module, I had this, my whole parser was one method. And that sounds stupid, I know, but stay with me. I was cargo coding that shit. I was looking at Ryan's HTTP parser, and that's what he did in C. So I was like, that's the way to go, one huge switch statement. That's what we need to do. And so unfortunately, the profiler did not tell me this was stupid, because he just saw one big function, parser.write, being really hot. And I'm like, OK, I already know that. So I didn't get very far with the parser. Even as I continued to make my module actually nicer and separate things out into different functions, I still find the parser to be lacking sometimes. Because sometimes I spend all my time in stuff like assigning properties to an object. Sure, I know this function is hot, but how do I make it faster? Why is it not fast? The profiler only gets you so far. Use it, but for some stuff it's not good. Also, another thing, this one is important, please listen to this one. Don't take performance advice from strangers, and I'm a stranger, because I don't know what your performance problems are, and I don't know what you're trying to solve. So any advice I give you is really in the context of my library, so only use it for that. There's one piece of advice that I think is kind of generic, but all the other stuff just ignore. Ignore all the stuff that V8 people tell you for optimizing your code and blah, blah, blah. I mean, it makes sense, but only when you have proven for it to make sense in your problem domain. So use this as good ideas and inspiration, but don't be cargo codey like me, like I was, taking the big switch statement idea and thinking that was great without ever testing it, actually. So what does work? I think BDD works. Oh, that makes no sense, right? Behavior-driven development? No, I mean benchmark-driven development. And that's what I do all the time. Benchmark-driven development looks like this. It's basically very similar to test-driven development. I only suggest to use it when performance is an explicit design goal, and it generally works best if you write the benchmark first and not after. So how do you do that? So basically, you create a function, benchmark, and that's where your code is going to go in. And I mean, it's really stupid and simple. And then you do this while loop. You take the time when you start, you run the benchmark, and you measure how long it took. Well, when you run this, obviously, it's going to say null, 0, because we're not doing any work yet. And if I just add a little bit of code, I'm probably going to stay at 0 for a very long time, because the JavaScript timer resolution is not very good. It's only giving me milliseconds, whereas some of those operations happen much faster. Don't go out and try to find a better timer. Just make sure that benchmark function does enough work so you get several milliseconds as a result. I suggest like 300-400 milliseconds is how long your benchmark function should run, and that's where it will produce good results this way. Anyway, so the next step is you implement a tiny part of your function. And that can be something really silly. For example, for my MySQL library, what I generally always start out with when I repeat this process to write a faster parser is I just parse the headers of the MySQL packages. So I get like a header that tells me how many bytes are going to follow, and then I skip over all these bytes and just parse millions of packages really fast. And this is good enough for my benchmark to slow down from 0 to something I can measure. And then I start to experiment. I'm looking at what can I do? What did the V8 people tell me? So this is when I remember the tips they gave me. But a lot of times I find that some of them don't apply at all, and some make a big difference. But you will never know unless you actually benchmark it. So I make these tweaks, I play around, I try different things, and I repeat it. And some of the results I get are surprising. So I found out that, for example, in my context for my library, try-catch is OK. I can do try-catches performance penalty is not too bad. I can do it. Big switch statement, bad. I already knew that. Told you guys. Function calls. I was surprised. One of the reasons I thought the switch statement would perform well is because it's all one function, so it has to be easier for the compiler. Turns out I can actually make almost as many function calls as I want in my very hot loop. It hardly has any impact because V8 is really smart at inlining or doing whatever magic. By the way, these VMs are magic. That's why I need to do this. I have no reasonable hope of ever understanding what's going on under the hood, so I need to do this trial and error alchemy style. Another thing I found by experimentation, buffering is okay. One of the reasons my original switch statement was so huge was because I designed the parser, cargo coding again after Ryan, trying to make it use as little memory as possible. So I was trying to never buffer any data. So if I was receiving a MySQL package, I would always try to parse the amount of bytes I already received without ever storing any up beforehand. So what I'm doing now, I'm buffering entire packages, and this results in much less housekeeping. I need to keep less track of the state, less track of where I am in a buffer. I can write much easier code. That's actually better. And I only found this out by benchmarking. I thought if I use more memory, it has to be slower. But actually, it turns out you can use memory in many situations to gain better performance. Here's my favorite one. I think you guys are going to like this one. So I have this function called parseRows in my parser. It very much looks like this. So it takes two arguments, the columns and the parser itself. The parser itself is hooked up to the socket, which pumps data into it. So it's a writable stream. But so whenever I have a row buffered up, this method gets called. And it basically loops over all the columns, which I get beforehand, and then I receive the column data. So I do this loop, and then for every column I have, I read one parser.read column value, one column value. And this is as simple as it gets, and I have to do this because I won't know the rows. I get those columns beforehand, but they're different for every query. So I cannot really optimize this code faster. At least that's what I thought for a long time. And the profiler was also like, you're creating an object or something, but I don't know. What can you do? So I set out to make this faster, and this is what I came up with. I'll give you guys a second to have a look. Does this make sense? OK. So what this basically does is it creates a new parser. It creates a new parseRow function and uses eval. What comes out of it is basically a static function that already knows what column values it's going to parse. So instead of dynamically adding these values to the object, it gives the parser, or V8, this work to do. And so we've heard all these things about eval being terrible and being slow and blah, blah, blah. Screw that. Eval is awesome. Here, I said it. So this is actually the C trick that got me the most performance for my recent parser, for the new experimental parser I'm working on. This thing was huge. It got me from parsing 350,000 rows per second to 450,000 rows per second. It makes an amazing difference. And again, I don't recommend this in all contexts. Only when it's your problem and you've proven eval to be useful. And you still need to make sure nobody's trolling you. As a MySQL server sending me back a column name that is escaping my my code, then crazy things will happen. So anyway, if you want to level up your game next, the next thing you can do is you can do data analysis. And the way you do good data analysis is to produce data points as tab-separated values. And so each line in your output should be one measurement, like the duration, how long your benchmark function was running. And then, tab separated, you add as much meta information as you can. So you add virtual machine metrics, so heap total. You add operating system metrics, like process RSS usage, and everything you can get your hands on that could be relevant to what you're doing, or irrelevant, because sometimes it turns out these things also impact. And the last one is the most important one. Do not mix data and analysis. This is my biggest criticism for all the performance benchmarking tools out there. They give me a framework to write benchmarks and performance things in, and then they will run my benchmark, and they'll be like, the median is this. Or they'll be like, this function is 2% faster. Or they'll draw me one graph. I mean, it's nice, it's convenient, it's fast, but it's nice and convenient and fast like something else. And this something else is running SQL queries from HTML templates. You can put these things together, it works, you get your shit done really quickly, but it's a mess to maintain, and it limits your options on what you can do later on. So don't mix those two steps. Produce separate files. Here's how to do it best. Run your benchmark, print your stuff on standard out, and then pipe it into T, the Unix utility, and write it into tab-separated value file. So you can watch the output while the data's coming out. Now that the benchmark has finished running, you get this pure data in a file, and you can analyze it. And for the analyzing, I recommend to use a tool that's really good for it. So that's the R programming language. I'm not really an expert, but ggplot2 is a library you can use to make really pretty graphs with it. The previous ones were used for that. And later on, I'll have a link where you get really good R tutorials that gets you up to speed in a few minutes. Another thing I recommend is use makefiles image magic to just automate certain things. So for example, R will produce PDFs, and then you can use make to automatically convert the CSV, run the R, or the tab separated values, make it run the R program, output PDFs, and then use image magic to get PNG images for the web out of it. And then there's a tool called Skitch for OS X that you can use to make annotations. So why do you need to do this? I'll show you a practical example of what I found. So I showed you this benchmark before. And actually, not only this benchmark, but all the benchmarks I showed you so far were kind of bullshit. Because I gave you little graphs that show this thing is faster than this thing. And they don't analyze anything. And this is what's wrong with most of the benchmarks you see out there. They don't go very deep. So when you go very deep, you sometimes it doesn't matter. But sometimes you find interesting things. And I did with this one. This is what I found. So this is a jitter plot, similar to the bar graph, but it shows me each data point that I recorded. And the x-axis doesn't matter. It's just randomly distributed for the library I'm currently testing. And what I can see is, the fuck? What is going on? Why do I have two data islands here? That makes no sense. It seems like sometimes my code is really fast, and sometimes it's really slow. I was really confused when I saw this, and I questioned my code for a long time. But here's the value of having your data separated from your analysis. You can dig deeper. So when you now plot this same performance data points over the time axis, it's not actually time, it's a iteration number for the benchmark, you'll see that both libraries make a huge performance drop at the same point in time, or the same iteration, and then they stay at terrible performance. So something happens there. Again, if you have more data, you can look what happened else at the same moment. So the next thing I found was, here's the heap usage of V8, or the heap total. So that's the total amount of memory V8 allocates for putting my objects in. And at the point where my performance goes to shit, basically V8 decided, I have 20 megabytes of heap, but I would like, I don't know, 35, and then my performance just goes terrible. And I have another benchmark that shows this pretty well, or another graph. This is a heap used. So you can see V8 is actually doing garbage collection. It doesn't look like I'm leaking anything. It's just that V8 decided, hey, this is where I should get a bigger heap, and it seems like it's the wrong decision. It could still be a problem in my code. I don't know, but these are the things you find when you do data collection well and you analyze it well. So yeah, collect data. Analyze it, find problems, tweaks the code, repeats that process. It takes a shit ton of time. There's no easy fixes, but that's the process that helped me to do these MySQL things. Thank you. I think we can do questions. I'm open sourcing this right now. So now it's open source. Cool.
Questions? No.
Okay.
Yes, sir.
Hey. I just remember some times where we had to doing this kind of performance improvements for other browsers, and we did really crazy stuff to get it faster. And then it turns out that other mechanics behind was optimized by V8 or other browsers, and so it turns out that the original idea was way faster than the tweak we did.
Oh,
so how do you handle that?
Okay,
do you keep the history of all your results and see, okay, I have to rework this for the new V8?
Yeah, so that's a good point. So sometimes you do crazy optimizations. For example, my eval thing falls in the crazy optimization category. And it could be that the V8 guys figure out how to optimize this case, and they produce a result that's much better than what I'm doing with eval. And then my eval optimization actually turns into non-optimal code. again, hard work, do it again, look at the data. So far, I was really lucky. I mean, I was bitching about the virtual machines being matching and all, but they're getting really, really fast. So I got huge performance increases from Node 0.4 to 0.6. It was insane. And 0.6 to 0.8 was also huge improvements. So the new V8 versions have helped me, but they could also hurt me if I'm doing optimizations that are really stupid. But generally speaking, the eval is the only crazy thing I did. For most part, my code actually turned out to be simpler and more modular. And not worse. So I'm not going crazy to just please the VM if I can avoid it. The eval thing is just fun.
Okay, that's it. Thank you very much,
Thank
Felix.
you.